Alright, video explainer number 2. This one is going to be for problem number 6 of the homework set 1. In this case, we have our good man Olaf here. He is enjoying the ice. He's standing on sheet ice that covers a football stadium parking lot in Buffalo. Oh, he's in New York. We're just going to ignore friction in this case. Let's just assume the ice is incredibly slick. I don't know how he's standing, but it's happening. So his friend chucks a ball at him at a very, very, very small mass amount. In this case, we are talking 0.400 kilograms of mass, which, in case you can't tell, isn't a lot. It's very small. In this case, it's being chucked at him at a whopping 10.8 meters per second. So, using this, we are going to look for the speed of which Olaf is going to get moved if he catches the ball. If it doesn't bounce off him or anything, he catches it and it knocks him back. So for this case, we're going to have to find the initial momentum, which is going to be coming in, much like the previous video explainer for number 5 that I did, although whoever's watching this probably hasn't seen that. He's initially at rest, so he's not included in the equation for the initial momentum. So in this case, our initial momentum is simply going to be 4.32 kilograms meters by seconds, because we just take the mass times the velocity, in this case m1 v1, to get our momentum of 1. So momentum is going to be conserved in this system because there's no outside force acting on it. So because of that, we're going to have a 4.32 equal is going to be the final as well, except for in this case, now Olaf has caught the ball. So we're going to add his mass to the mass of the ball, and we're going to solve for the second velocity final, or v2. I usually use, fine, we'll make this an I. So that's mass 1, that's velocity initial. So we're going to solve for velocity initial. So if we rewrite, that's just going to be 4.32, assuming units are the same as these, just kilograms, meters, seconds, meters divided by seconds. And over that, underneath that, we're going to have our new mass, which is going to be 69.9 kilograms, and that will equal our velocity final. In this case, our velocity final is going to be, and just to keep it in nice, easy SI units, I'm going to turn it into scientific notation of 6.18 by 10 to the negative 2 meters per second. Because if we divide, obviously, kilograms by kilograms, those cancel out, leaving us just with meters per second. So that is our velocity for the first part of the equation. So I'm just going to erase some of these, just so I have a little room to work with here. So that's still there. I'll just rewrite that up here. VF 6.18 meters per second. Now, we're going to look at something a little bit different here. In this case, we're not having an inelastic collision. We're having an elastic collision because the ball is now going to ricochet off Olaf because he has butterfingers and can't catch it. So what's going to happen is we're going to have a new direction. So first we're going to take a look. So the ball is horizontal. Let's just assume that the ball gets thrown in at a positive value. I'm going to check and see what Pearson pumps it out and answer out as. Yeah, we should be fine. Okay, so the ball comes in at its initial velocity, so we're still taking into account that 4.32 kilogram meter seconds. That's the initial momentum, so P of I. Now, in this case, we're going to have the ball of, again, 0.400 kilograms. It's going to bounce off him at 7.9 meters per second in the opposite direction. So in this case, technically we can't have a negative direction or a negative speed, but I'm just going to put it in little parentheses there because it's technically going in the opposite direction. That's just so that when I finish this equation out, it's going to look nice and pretty, because we're going to have instead negative 3.16 meters per second. So kilogram meter second, sorry, one more unit there. So that's how much momentum is essentially continuing to move with the ball. But then now it's moving in the opposite direction. Let's just say this one went in this way, this one went out that way. Actually, I might swap that just because who knows. So it went in, it hit him, and it went back out. So in this case, the delta P, or the impulse, is going to be equal to our good friend Olaf here and how fast he's going to be moving. So in this case, we're going to have his mass of 69.5 kilograms multiplied by the velocity. We'll call it, what does Pearson call it? They give it a fun little value. It's just another VF. It's different than the previous VF though, because what's going to happen is that the difference between these two, well, the change in these, so obviously it's not going to be 1. It's actually going to be, if I remember correctly, double check my notes. I'll just math it together, I suppose. So it's actually going to be the delta. So the difference between those is going to be 7.48 plus 3.16. So we're going to have a delta P value, how basically the absolute value between those two boys. Delta P is going to be equal to 10.64 in this case. So we're just going to quickly rearrange our numbers here. So we obviously know delta P now. We know the 69.5K. We just need to find velocity final. So velocity final is going to be our 10.64 divided by our 69.5 kilograms. Sorry, I guess that's G there. And in this case, this is still a momentum value, so it's still going to be in kilograms per meter squared. Because when we divide this out, we're going to get a velocity value that cancels out those kilograms, giving us just meters per second. In this case, if all the math is run correctly, we're going to have 0.108 meters per second. Not very fast. I mean, if you get hit by a football on sliding ice, obviously you're not going to... a person is a little bit heavier than a football. They're not going to go too far. And that's even not including friction, which makes it fun. So this is our final answer here. And if we check in and on our lovely Pearson, it seconds that answer as well. So that is the case for the elastic collision. So there's the two answers for that. And that is the end of video explainer number 2.